Good afternoon, everyone. We are the Cloud Innovators team from Group 3 from Seneca Polytechnic, and today we are going to present our CA Capstone project BoxBuddy. BoxBuddy is a cloud native subscription meal ordering platform where we designed this solution to bridge the gap between local kitchens and modern cloud scalability using AWS. And today I will take you walk through our team, the challenges we faced, our architecture, and finally a live demonstration. So before doing that, let me introduce to my team. So myself, I am Chandan Murthy, and my role was back in DevOps. I focused on containerizing our application and managing the infrastructure.
Hi, I'm Muslim Dahal. I'm the tech team lead and full stack developer of this project. I oversaw the overall system integration and led the implementation strategy.
Hi, I'm Jeevan. My role for this project was a backend developer and responsible for documentation. I handled the API logic and ensured our project documentation was detailed and accurate.
Hello, I'm Nitin Surabhi, the quality assurance lead. I was responsible for defining our architecture and flow and testing our success metrics.
Hi, myself, Darshan, and I'm the full stack developer, and I focused on building the user interface and connecting the front end features with the backend. Thank you.
So let me discuss the problem and challenges we faced in our project. So why BoxBuddy? So we analyzed the current landscape of food delivery and identified image like hurdles of both consumers and businesses. So the first thing was high cost and inconsistency. So existing services are expensive and the quality is often unreliable. And we also know they have lack of transparency. So this is big one. Customers cannot track the preparation or packaging stages in real time, and we also see they have poor flexibility, like policies on cancellations and refunds are often rigid and frustrating. And we also see like the restaurant integration, like we know restaurants often struggles to implement this level cloud native systems. And we also see some static asset delivery, like serving high quality food images globally without latency is a major technical challenges. So BoxBuddy was built specifically to solve these issues.
So moving on from the challenges we just identified, let me introduce to you to our answer, that is BoxBuddy. We designed BoxBuddy as a sophisticated cloud native meal subscription platform that directly addresses the issues like high cost, lack of transparency, and poor scalability. Our solution is built on four main pillars, that is real-time engagement. We offer full visibility, allowing users to track orders from the kitchen to the door. Dynamic management, we built an admin portal that handles dynamic meal updates and automated refund workflows. Secure and global, we utilize the CloudFront for fast global distribution, ensuring our front-end loads instantly anywhere. Then the scalable architecture, by using the AWS managed services, our infrastructure is highly available. So why is this feasible? Because we leverage Docker for portability and Terraform for rapid automated deployment.
Yeah, thanks, Jeevan. So let's look at the specific feature of the project box buddy offers, broken down by category. So the first is the user features, and we have a secure sign up and login using JWT auth. Users can browse meal. Users can browse meals, add to cart, and check out. Crucially, they can get shipment tracking via a reference ID and receive notifications via SNS. And next is the admin features. Admins can log into a add or edit meal info, view all orders, and change statuses. Uniquely, they can approve refund requests directly from the dashboard and monitor database metrics via CloudWatch. And the next one is the platform features. And under the hood, we use CloudFront for global delivery, secure OAI based SC3 access, so no one touches our buckets directly, and a Dockerized backend provision via Terraform. Thank you.
So Here is a complete architecture overview of a BoxBuddy platform showing how each cloud component works together to deliver a fast, secure, and a scalable meal subscription experience. So, at the center of our architecture is Amazon S3, which stores the private React build of our front end. To ensure secure global delivery, we use CloudFront with an origin access identity. So all front-end traffic is authenticated and restricted from public access. And DynamoDB functions as our main database, storing meals, orders, user profiles, and refund requests with low latency performance. To maintain operational health, CloudWatch monitors DynamoDB and trigger alerts for read-write capacity changes. On the application side, our React plus TypeScript frontend communicates with the Node.js and Express backend API, which handles authentication, order processing, and admin operations. And JWT authentication is used throughout the system to secure all user and admin sessions. So finally, the GitHub serves as a version control hub, enabling seamless code collaboration across the team.
So here is a summary of the technology stack that we use to build this architecture. S3 that hosts our private React front-end build. Then the CloudFront provides our global CDN with the origin SS identity, that is OAI for security. DynamoDB stores our meal orders and user data efficiently. Similarly, the CloudWatch that provides the alarms for scaling decisions. Another one is the development tools that we used. We use React plus TypeScript that's Byte for UI, Express.js plus Node.js for the backend API. Similarly, the JWT for authentication and GitHub for the version control. Thank you.
So our next slide is our implementation journey, phased approach. So here we have like 4 different phases for the project. Starting from phase 1, it's backend containerization. So first we build and run the backend via Docker and then validate with the health. Then also we tested the API routes for the first phase. On the phase 2, we did front-end configuration where we configured the environment local variables. Then we also build the front end via White and also use the check the UI based loads. For the phase 3, we did cloud infrastructure deployment. Finally, here we created the private S3 bucket and also applied some bucket policies to the bucket. We also deployed CloudFront and major infrastructures with Terraform. For the phase 4, we did automation and monitoring, where we used CloudFront validation and CloudWatch, where we set up some alarms for DynamoDB and some messages for the SNS and also some admin dashboard refinements. So our measurable success criteria is the sites will be loaded in the real time in a less number of time via CloudFront, and we try to ensure the rapid content delivery. The second success criteria would be API response time, where it's under normal load. It should ensure the quick interactions. Also, CloudFront availability, where it should guarantee the continuous service. Uh, Private S3 bucket, where it's verified by a OAI policy for the security. Also, CloudFront S3 cost and UI responsiveness to optimize the student workload and also be smooth for all the devices respectively. So if you have any questions, you may ask us. We have stated time for the BoxBuddy project. And finally, we're moving up to demo, which I'll be presenting. Can you see my screen?
Yeah.
You can see my screen, right?
Yes.
Yeah. So this is the CloudFront from where we have been hosting the application. Using this DNS name, we can access the application. I'm going to show you later on. Here we have CloudWatch, where we have set up alarm for the database. So any sudden changes in the database can be tracked here. So here we have SNS messaging.
Your screen isn't visible.
No? Can you see my screen?
Yeah.
Okay, so this one is the CloudFront, where we have been using the DNS name to access the application. This is the CloudWatch area where we have set up alarm for the database and sudden changes in the tables. So this one is MSN SNS for publishing the messages and subscriptions. So we have the API gateways for getting user emails and creating orders. So this kind of routing is done by API gateway. Here we have S3 buckets to store all the static files and the project itself. And we've been working on the Cloud9 environment. So this is the environment we're working on. We have all the codes in the box body area. So this is the repo for the codes. So finally about this project, this is our home page and this is the normal like a normal section. Here a user can just normally create a new account. So suppose I'm creating a new account for so if I'm creating a new account as a user, so it's gonna show like this. And normally what I do is I'm gonna add some mails to my cart. It's gonna show the message. I'm still visible, right? Okay. And if I see the cart and I can again change some items, so it's gonna be the frequency is gonna be per week. And if I go to proceed checkout and enter some details, not my real details for now, it's gonna expire something. So normally it's gonna place the order like this, and I can use the same reference number to track the order itself. So if I insert the number, it's gonna show me that the order is being processing. So apart from this, a user can go inside and view more details about the product, like the price and the quantity per week. So it's going to be per week. User can also view the required number of protein and carbs and all these details here. So normally what the user can see in the dashboard is he can request a refund and cancel the order. And he or she can also track the order from here, from the order history. He can delete his account from here. So normally if the user refund or request to cancel the order, he can just like go over here and say refund it, just cancel it. So now if I'm gonna go from login as admin here, if I'm logging as admin, so in the dashboard I can see I can add new meals, I can do all these things, I can update these things, update this. So normally I can also process refund because the user wanted some refund, right? So normally if I do some refund, the user can see. Let me log in as the user I had created before. So if I see as like this, so it's gonna say me refunded. And basically a user can see those things, and also the shipping methods. Admin can change the shippings. So normally if I'm adding the same thing again, and if I'm proceeding to check out, if I'm already paid for this, and if I'm logging in as admin once again, so from the admin section, I can I can change the status of the delivery from shipped package or maybe delivered. So if I say shipped, and again, if I log in as the user I did before, I can see in the order history that the tracking is so changed. So basically our project is about the shipping and delivering the right meal to our customers. So customer can track their order and track the meals and get notified instantly. So that's all our project is about. Thank you so much.
Thank you, Professor.